Hi, everyone. Okay, let's get started. What answers did you get for the first one? Okay, good. 742 is correct. Nidhi, can you explain?
Yeah, so this was just a two-step equation. I set up, well, two systems of equations. I set up x plus y is equal to 1242, or 48, excuse me. And then second equation is x plus 2y is equal to 1754. And then if you just subtract the two equations, you get y is equal to 506, 5.06. And then if you substitute that back in, you get x is equal to 7.42.
Okay, good. Yep, this is one way of doing it. Anyone else do use any other approaches? Okay, so there's one more thing you can do, which ends up being exactly the same as this, but you know that there's a fixed monthly fee plus an hourly charge, right? So if December is the fixed monthly fee plus the hourly charge, January she used double the, or January he used double the connect time as December. So that means the extra connect time cost is the difference between the two, and that must have been the connect cost of December as well. The difference between these two is 506. That was the connect cost. So all we have to do is subtract 506 from 1248, and we'll get the difference as 742. So the connect cost we know is the difference between the two, because the double the usage in January than December. If you subtract that usage from December, you get the fixed cost. So roughly it's the same as doing this algebraically, but you don't need to define a variable. You can just kind of look at the differences here. 506, subtract that from 1248, and you'll get 742. Any questions? Okay, let's go to the second one. Okay, good. 8 is correct. Ishan, can you explain?
Oh yeah. So I just made like a triangle and then I did 4, 6, and y. And then for like y to be like a viable number, you have to follow like the side rule. It's like if you have sides A, B, and C, A plus B has to be greater than C, A plus C has to be greater than B, and B plus A has to be greater than C. Uh so and B plus C has to be greater than A. So basically what you could do is we could say 6 plus 4 is greater than y, 6 plus y is greater than 4, and 4 plus y is greater than 6. So we know the minimum value y can be is 3, and the maximum it could be is 9. And then it's just like x and y are just like they're in two similar triangles. So you could just like write the same inequality for these. So you could say y is in between 9 and 3, and x is also in between 9 and 3. So like we're trying to find like that's not a possible value, the least value. So we just have to like add 1 to our max and subtract 1 from our minimum. So we get 10 and 2. So 10 minus 2 is just 8.
Good. So yeah, you can do this. The key idea is this triangle inequality, which basically says that two sides, the sum cannot exceed a third side. Or sorry, the one side shouldn't exceed the sum of the other two sides. And you just can apply to any pair of sides in a triangle. So if you kind of apply this in each direction for two of the three sides of this 4, 6, and y being the sides, you basically find that y needs to be between 2 and 10. And you can also see that here because if I had y equals 2, this would essentially become a line, right? So if I had a side of 4, a side of 2, and a side of 6, it's 4 plus 2 is equal to 6, right? So it's almost this kind of like degenerate triangle because you have a 4 and 2, you can just put a point in between, and that would essentially become your triangle. Because one side is 4, one side is 2, And to make a side of 6, it would be the sum of the two. So that's kind of the intuition for where this rule comes from. So now that we know this third side is between 2 and 10, we want the smallest possible number that is not a possible value of x minus y, the absolute value. So x minus y, x and y are both potential values of y here, or potential values of this third side. So if it's between 2 and 10, kind of the maximum difference, what is the maximum difference that this could be, x minus y? So what are the extreme possibilities we can make the choice for x and y? We know y is between 2 and 10. So this means that x is also, so this is the same as x is between 2 and 10 as well. How do we make the difference between them as large as possible?
The way that it could be the largest as possible is creating like as x is the largest number and then y the smallest number, so it would just be 10 minus 2.
Good. The only piece that's a little tricky here is we can't actually make it equal to 10, right? 10 is not allowed. It has to be less than 10.
Oh, like 9.999.
So the best we can do is 9.999. And what is the least we can go for y?
Would it be like 2.00001?
Good. And what is this difference approximately?
It's around the same at 8.
Good. It's 8 minus a little bit, right? We can call this epsilon, which is like some really small number. However small you make it, it's like 0.000001. We can make x 10 minus that, and we can make y 2 plus that, or 2 plus a little bit. So this difference is just a little smaller than 8. So if we think about it, the smallest possible number that is not a possible value of x minus y would be 8 itself, right? Because it has to be 8 minus this tiny bit. We can't actually reach 8 because we can't actually reach 2 on one side and 10 on the other. If these allowed it to be equal, then 8 would have been possible, right? So the smallest number that is not possible would have been above 8, 8.1 or 8 above 8. Because we can't actually reach 8, we know that the smallest positive number that is not possible value for this is 8. Does that make sense?
Yes. Just a really quick question about epsilon. So that isn't specific to like triangles or anything. Like you can use that in any mathematical way for a number that's close to a value. Is that correct?
Usually it's used for like something that's can be infinitely small. So as you kind of go, other things you might say that its limit is to go to 0. Or like, so imagine as small as a number you can pick that doesn't actually equal 0, but it becomes smaller is usually what epsilon is used, but you could define it kind of however you wanted in different contexts, as long as kind of you define what it is. But you can say that as this goes to 0, this is still true, but when it's actually equal to 0, this is not possible. So it's just, we can think about it as a very small number.
Okay, thank you.
Any other questions? Okay, let's go to the last one. Okay, good. Thursday is correct. Nidhi, can you explain?
Yeah, so I first started and I wanted to determine if we know that n is the 300th day of year n is a Tuesday, 200th day of year n plus 1 is a Tuesday, and we're trying to find the 100th day of year n minus 1. I wanted to figure out if one of those were a leap year that could like change our set of numbers. So I did that by finding 266 as the leap year day and then 265 as the normal day. Normal year. After finding those numbers, I divided both by 7 because of the days, and I got that 266 divided by 7 is equal to 35, and 256 divided by 7 is like a repeating decimal. So we know that the year with 266 is a leap year, so n is a leap year. From that information, we know that n minus 1 is not a leap year. So we can find that 265 plus 300, which is the difference between the two, is equal to 556. I'll just give you a sec to finish that one. And then after finding that 265 plus 300 equals 565, I took that number and divided it by 7, again, the days of the week, and I got 80 remainder 5. And so we know that means that the remainder of 5 that means it's 5 days before the Tuesday, and so 5 days before a Tuesday is a Thursday.
Good. So yeah, that definitely works. And the key idea here is the remainders between, sorry, there should be 0 and 6, right? So the key idea is you have to think about when you move a year, if you have some number of days, every multiple of 7 is the same day of the week. So the biggest kind of important factor here is what is the remainder when you divide by 7? So the general idea is kind of the same however you do this. There's a couple of different ways, and I'll kind of show something that's slightly different from what maybe explained, but kind of the same idea. Let's use one fact. When I take the same day of the week, or sorry, the same day, let's say it's January 15th. If 1 year in, let's say 2023, and let's say that's a Monday, what day would it be in 2024, the same day?
Tuesday.
Good. Why?
Because like since there's like 365 days in a year, it's not divisible by 7. So there's always gonna be like one remainder, and that remainder pushes it forward a day.
Good. So this is something interesting that you might have observed with your, let's say, birthdays or something like that. The same day in a consecutive year kind of shifts by 1 day of the week forward. So the same day of the week, as long as it's not a leap year. So every year when you move 1 year on the same day, it becomes 1 day kind of forward in the week. Because when you look at 365 days in a year, it evenly multiplies 7 up to 364, and there's a remainder of 1. So that pushes you forward by 1 day a week, 1 day of the week. Now let's see what happens in 2025. What day of the week does it become then?
Wednesday.
Is there a leap year in between?
I'm not sure.
So 2024 would be a leap year. There would be actually 366 days because Feb will come after this, right? So it's 366 days. What would
Thursday?
Good, yeah, Thursday. So
I would be
Yeah.
Thursday because February still hasn't come yet, so the extra day isn't there.
correct, you're right, but because also 2024 is the leap year, right? So there is
Oh, it's the year after.
huh?
Uh-huh.
Between 2024 and 2025, that February date comes, right? Feb 29th of 2024 is that extra day that you have there.
Okay.
Does that make sense?
Yes.
So that 366 divided by 7 should give you a remainder of 2. So basically what this means is when you take the same day of the week and the same day of the year and move forward a year, it shifts by 1, except for leap years when it shifts by 2. So let's think about year end of the 300th day is a Tuesday. So in a normal year, the next year, the 300th day would be a Wednesday, if it's a normal year. If we just look at the 300th day of n plus 1, or it would be Thursday if the n plus 1th year is a leap year. Now, if we're looking at the 200th day, that's going 100 days back. So if we go 100 days back, 100 days is like 14 weeks, because 14 times 7 is 98, plus 2 more days. So 100 days back would be going 2 days back in the calendar, right? So Wednesday in a normal year would be Monday. The 200th day would fall on a Monday. And if it's a leap year, the 200th day would fall on a Tuesday. So we know that the 300th day, the 200th day of the n+1th year is also a Tuesday, thus n+1 must have been a leap year. Now we want to go to the 100th day of the n-1th year. So again, we know that the 300th day of the n-1th year would just be going back 1 day, right? So let's do that. So if we know that 300th day of year n is a Tuesday, the 300th day of the n-1th year would be just 1 day backwards, right? Monday. Now we want the 100th day of that week. The 100th day of that year is how many days back? That's 200 days back. So 200 days back, we know that 196 is a multiple of 7. So it's 4 more days before that. So 4 days before Monday would push us to Thursday. Does this make sense?
Yes.
Okay, good. So it's the same idea that Nidhi explained. You can do it by looking at between the 300th day and 200th day, how many days there are. So 266 or 265 days. Alternatively, you can just think about moving the same day between different years. The 300th day of the year n+1, the 300th day of each of the corresponding years, and then move backwards in that way. Any questions?
No.
Okay, that's it for today's class. We'll see you all next week.
Thank you.
Thank
you.
you.